Get turned to today's webinar, where we have our speaker, Deborah Landau, Dr. Deborah Landau, speaking about fire history and ecology in Maryland. And I had the pleasure of seeing a small snippet of Dr. Landau's work yesterday. We held a early succession habitat summit related to northern bobwhite quail, and we had great attendance. There's I think 80 people in the room and 25 people online. So 100 people joined us yesterday to learn about early succession and habitat and recovering bobwhite quail populations. And Deborah was one of our speakers. So she'll be adding to that, to my body of knowledge today, I'm sure. And she Dr. Deborah Landau is a conservation ecologist with the Nature Conservancy and the Maryland, DC chapter. I actually think she's she's a director. I didn't update her title, but I think she's actually a director of. I don't want to say because I'm not going to get it right. But Deborah, please correct us with your title when you get started. But here's her email at the bottom: is dlandau@tnc.org, and she does a lot of great work. And I'm looking forward to learning a lot more today.
All right, terrific. Well, thanks so much for the introduction and thanks for having me. So yes, I got a promotion. My title is Director of Ecological Management, and I have been with the Maryland DC chapter of the Nature Conservancy for 21 years. And yes, I really enjoyed the grasslands workshop yesterday, Luke. Really interesting stuff about quail. And I'm a little embarrassed to realize that for this wildlife talk, I don't have a single picture of quail. So we'll just have to.
Well, it is a woodland wildlife webinar, so right. Quail are in the grasslands, so you're safe. You're great.
All right, thank you. So my principal job role is ecological restoration, and we've got lots of effective tools, but one of my most powerful tools is controlled burning. So I'm always really excited to talk about that. So first, a little bit about the Nature Conservancy. Our mission is to conserve the lands and waters on which all life depends. We have programs in 74 countries around the world and in every state in the US. But this is how I see the world. I'm from Maryland. I'm a Maryland native. And my world is our preserves in Maryland, and we have them throughout the state. We've been burning the longest up in Cecil County at our pilot Serpentine Barrens Preserve. We've been burning there since 1990, but we probably do the majority of our burns down at our Nassawanga Creek Preserve on the lower shore. It's a 10,000 acre preserve, and I was telling Luke that now we're pretty good at doing about 1,000 acre burn at a time. And those have been going really well. But increasingly, we've expanded our burn program into Western Maryland. We started burning there a little over 10 years ago. And we're really focusing a lot of our burn efforts there now. So a little bit about fire. What we know, fire has been a part of this landscape for many thousands of years. When I talk about fire, I talk about reintroducing fire into the landscape. And most species in Maryland are well adapted to fire, and many are actually fire dependent. But our forests are altered, and many communities, such as our pine and oak communities, are in decline. So how do we know that fire used to be here, and how do we decide what the landscape looked like, and maybe what we're trying to not work towards, but what we had before we arrived? So one thing you can do is look back at records, and we have an astounding number of records. Here I've listed over nearly a dozen of documentations of early settlers arriving and reporting seeing Indigenous people using fire or just fires on the landscape. And even John Smith, I've got a quote here from him where he observed that Accomacs hunting using fire and talking about how they would use the fire to surround the deer and then effectively hunt them. So we do have quite a few records of Indigenous people here in Maryland on the Eastern Shore using fires. Gerald Williams has a really excellent summary of hundreds of studies about Indigenous peoples' use of fire. And he kind of summed it up into 11 major uses of fire. Hunting clearly was one. They also used them for crop management. They used them for fireproofing areas. So Indigenous people were absolute professionals at using prescribed fire, and they absolutely understood that prescribed fires prevent wildfires. So if they burned the areas when they wanted to burn them, when they could control the fire, they knew that then they wouldn't have a wildfire at a time that they didn't want and in a place that they didn't want. And they also used them to collect insects for eating, but also for pest management. Indigenous people were well aware, and I will talk about modern studies in a bit, but that burning through the environment will reduce tick populations. And they also used fire for warfare and economic extortion and for clearing areas for travel. So a tremendous amount of uses of fire before we even arrived. And that's one of the reasons here in Maryland that we believe that the majority of the fires that were occurring were set by Indigenous communities. So post-settlement, even after the Native Americans were displaced, 17th and 18th centuries settlers continued to use fire for many of these same reasons: to clear land, to drive game, to clear the undergrowth. And they also understood that burning did reduce tick populations. There's a number of references about that. But then in the 19th and early 20th centuries, the character of fire really changed. And what was happening is a lot of the logging operations were shifting from small to really large industrial scale logging. And what was happening is enormous swaths of land were being clear cut, and all that slash was being left on the ground to dry. And these trees were pulled out using these narrow gauge steam engines. So you had a combination of drying slash in these big areas that were exposed to the sun with these steam engines spitting coal. And you had these absolutely horrific wildfires that were occurring. And the result was a very aggressive program to suppress wildfires. So this graph is specific to the Appalachians, but I think it's absolutely relevant throughout Maryland. So historically, we had fires that would always kind of occur in waves. We'd have drought years and then there'd be lots of fires. And then we'd have wet years and there'd be far fewer. But throughout history, at least we know as far back as 1500, and I'll go further back in a bit, but that wildfires were occurring at a regular basis until about the 1900s. And this last peak, I think, is when we had those catastrophic slash fires. And that's when fire tolerance was really, Smokey Bear was introduced, and the Forest Service really put their foot down on wildfires. Although it really wasn't until the mid-1940s, after World War II, that mechanization really improved enough so that the Forest Service could effectively actually put out those fires. But after that point, fires essentially disappeared from our landscape. So why don't we have fires today? Well, obviously, if you see a fire, you're going to pick up the phone and call the fire department, as you should. We don't want anybody to get hurt or lose their home. So there's active fire exclusion. We'll actively come in and put them out. But even if there were a wildfire in an area that wasn't going to negatively impact anybody, that wildfire is eventually going to hit a barrier. So either a road or an apartment building or a Walmart, but essentially we don't have these large compartments where a fire could just race for miles and miles. It's going to hit some sort of barrier. So essentially we no longer have these landscape scale fires that we used to for quite a number of reasons. So what does this mean? What are the implications on today's habitats? So let's talk about a typical modern forest. When I go for a hike in my backyard, this is what I expect to see. I'll see a whole lot of trees, maybe 300 or more trees per acre. Not a lot of herbaceous understory, maybe a few dozen species at most. And if I veer off trail, I'm probably going to hit a wild greenbrier. It's very closed in, kind of dark. But historically, what we think we should be seeing and would have been seeing are more open park-like environments with fewer larger trees, maybe 40 to 70 trees per acre, but a tremendous amount of herbaceous understory, hundreds of species per acre. And in fact, there's accounts of early settlers who would describe it being so open that they could drive their horse-drawn carriage through the woods. So this is kind of what we feel that we should be working for and visualizing in our head. I didn't include here, but I also have another slides from out west where they have pictures where today you'll see that you expect to see a close forest of ponderosa pines all really close to each other. But historically, maybe what we should have seen is more open glades interspersed with these forest woodlands. Here's another example of a before and after picture. This one's from Tennessee, but I liked it because it really shows the amount of herbaceous diversity that will come in after a fire. So this is an area in which fire was excluded for a very long time. And you can see there's just a thick mat of leaves, not a lot of light reaching the ground. And after all they've done here is reintroduce fires, a lot of those smaller trees have been killed, and you just get this amazing diversity of herbaceous vegetation. So how do we know where to burn? So we do know that more than half of the world's terrestrial ecosystems depend on fire in order to maintain their character and their biodiversity. And essentially all of North America is considered to be fire-dependent habitat. Another thing that we can do to kind of look backwards is we can look at pollen records. And Grace Brush did a really interesting series of pollen cores right here in our own backyard. She collected pollen cores from the Anacostia River, I think actually a tributary into it. This is just before they were building the Greenbelt Metro. So she took these pollen cores, and what she found was really interesting. So here on the left is depth. So this is how deep the pollen cores went. And right here is about the time of European settlement, colonization. So if you look way over here at the charcoal, you can see this tremendous amount of charcoal that was being deposited in the sediment before Europeans arrived. What I think is interesting is here, if you look at sedimentation, this is, so after Europeans arrived, this is all the sedimentation that occurred after that, all of that tremendous amount of logging. And you can also see there's a couple of really cool things here, like the blueberries during the fire period were producing a tremendous amount of pollen. And indigenous people knew that fire really increases blueberry production. So there are a lot of signs that you can tell going 12,000 years back now that fire had historically been occurring on our landscape. Another way that you can try to get a sense for what kind of fires were occurring is to look at the trees that are here. So what this map is showing us is ranges, historical ranges of fire-adapted eastern pines. So the first one I'll draw your attention to is longleaf pine here in red. Longleaf pine is extremely fire dependent and in fact requires fires about every 2 to 3 years to maintain. And longleaf pine had almost reached Maryland's eastern shore before European settlements, and then they started cutting them back, and now its range is considerably smaller, but it was in this area. But we can also look at this yellow hatch mark here is pond pine, Pinus serratina. And then we've got shortleaf pine, and pond pine is shortleaf throughout the Delmarva Peninsula. We've got pitch pine all over our range, and all of these are fire-adapted pines again. And the one that I think is the most interesting of all is Table Mountain pine right here in the Appalachia. So let me talk a little bit about Table Mountain pine. Table Mountain pine is endemic to the southern and central Alps. It is not found anywhere else in the world. And Table Mountain pines have serratinous cones, and that means that they are glued shut with sap, and they'll only open when exposed to heat, like from a fire. And you can go on a hike along the Central Alps and go on the ridge top, and you'll see some really nice, beautiful, mature Table Mountain pines, but you won't see any pine regeneration unless you're in an area that had a wildfire or a prescribed fire. So this is a magnificent endemic tree that we will lose forever if we don't return fire to the landscape. So let's talk a little bit about fire adapted trees and kind of where they sit in terms of needing fire. So I had a Chesapeake Conservation Corps intern who she expressed it as a fire adapted species continuum, and I love that, so I'm going to use her analogy. So if you look on the left side of this continuum, you've got fire dependent trees like the Table Mountain pine. They have to have fire in order to be able to regenerate. But then you've got the fire adapted trees. These are trees that can do really, really well with fire. They have really thick, chunky bark, so they're physically protected. And so these are like oaks and the yellow pines. And they also have fuel characteristics that can promote fire, which is sometimes why we call these fire facilitators. For example, oak leaves, when they fall from the tree, they curl up as they dry. And as they stack on top of each other, there's a lot of air in between these leaves. And you can picture as you walk through an oak forest how crunchy they are. So when a wildfire or any kind of fire sweeps through an area with oaks, those dried oak leaves are going to pull fire across the landscape. So they'll encourage that fire to keep moving. And so they're adapted to these periodic surface fires. They also have really, really long tap roots. These trees tend to be very, very drought resistant, maybe because often you'll find them on south or east slopes. So then you've got the fire resistant trees. These are trees that can survive fire just fine, such as the white pines, but they are adapted to longer intervals, meaning if a white pine seedling is, say, 3 years old and a fire sweeps through the area, it's probably going to kill that white pine. But if that pine gets to be 10 or 15 years old and a fire comes through, the pine will survive. So these trees are adapted to areas that have somewhat longer fire return intervals. And finally, you have the fire impeders or the fire intolerant trees, such as gums and maples. These trees have very, very thin bark. And what's interesting is when their leaves fall off the tree, they're very, very flat. And if there's any little bit of moisture in between these leaves, those leaves are going to hold that moisture for a very long time. So then what happens if a fire sweeps through an area and reaches one of these trees with this wet mat around it, it's going to put the fire out, and it will prevent that fire from continuing across the landscape. So what's happening over time, because we have suppressed fire and removed it from the system, is we're getting more and more of these wet trees, these fire impeder trees, or you could think of them as mesic trees. They really like it wet. And you're getting fewer of these fire adapted, drought tolerant trees. So there's a term that's called mesification. So our forests are becoming more mesic, they're becoming wetter. And the long-term implications of that really aren't good. We know that with climate change, we're going to have longer periods of severe drought. And so over time, if we end up with a forest that has more of these mesic trees and fewer of the drought-tolerant, fire-adapted trees, when we do ultimately get these droughts, and we know we will, the forest is going to be very stressed, and you'll have much, much more mortality from the drought or from disease or from pest outbreaks than you would if you have a forest in which you've had periodic burns, and that forest is going to be very resilient and be better able to withstand the droughts. So another way that we can look at how often fire was occurring on the landscape is to look at fire scars. So I talked about these fire adapted trees like the oaks and some of the yellow pines. And they're able to survive a fire, but often they will be injured. So if there's say there's an oak and a fire sweeps the landscape and it injures the tree, that tree is able to heal over that injury. And so we call that, it's compartmentalizing the injury. It'll heal and then it'll fill it with sap. But when there's a subsequent fire, fire is much more likely to get caught in that little groove. So it's going to burn again. And if it's full of sap, again, it's going to burn. But again, that tree will heal over. So every time there's a subsequent fire, it's going to burn that scar and then the tree will heal. And now what you've got is what we call a recorder tree. So every time that that tree has experienced fire, it has captured a record of it. So what we're doing is we're going through the woods and looking for these recorder trees. Many times they've fallen, they're already dead, and we'll take sections of them and we can find these fire scars, and it's just a treasure trove of information. So this one tree cookie is what we call it, this one from our Sidling Hill Creek Preserve, captured a fire from 1814, 1840, 1876, 1885, and 1895. All of this captured on this one piece of tree. And what's also really interesting is you don't just know the year, but you can know the time of year, depending on whether that fire scar was laid on the early wood or the late wood. So during the growing season, so whether it's the growing season is the light part and the dormant season is the dark part. So you can get a tremendous amount of information from these trees. And a study that we've recently finished showed that in Catoctin Mountain, we were finding about every 5-year fire return interval. Indian Springs Wildlife Management Area about every 7 years, and at our Sidling Hill Preserve, fires appear to have been occurring about every 8 years. A much larger version of this similar study occurred at Savage River State Forest, and it's a sad story. There was an old growth forest with trees that were over 400 years old, and they were logged, and a road was put in to reach the trees. And this road cut through some enormous trees. So what these researchers did, Shumway and Abrams, is they found these enormous stumps and they cut huge tree cookies off of them and looked at the fire scars that were captured in these 400-year-old trees. And what they found was they sampled 20 trees, 19 of them had fire scars. And they found 42 fires between 1616 and 1959. So they came up with an 8-year mean fire return interval or fire frequency interval. So that's some pretty powerful information telling you that there in Western Maryland, fires appear to have been occurring about every 8 years. They only found 4 fire scars after 1930 and 0 after 1960. So we know that fire is a powerful tool. We know that fire had been occurring historically. So why not, we can just put fire back everywhere. Obviously, no, fire is really hard. You need permits, you need plans, you need very careful prescription, you need crew and equipment, you need just the right weather. So if you can't burn, are there alternatives? Well, sure, there's lots of things that you can do as fire surrogates, for example, logging. And we have used this quite a bit on a number of our preserves. And I'm going to give you an example here of our Naswongo Creek Preserve, which we purchased with lots of loblolly pine plantations on it. And so we have been harvesting these pines and slowly transitioning it away from a plantation, but in one of the stands, it had been planted in a wetland and we had a series of drought years. And we realized that we could come in and completely clear cut all of the loblollies from this plantation. So we did from the wetland. And the results were fantastic. And we were really surprised to find from what had been formerly just a pine plantation with nothing underneath. We had 7 white-fringed orchids appear and a handful of these yellow-crested orchids. So that was super, super exciting just from having more light reaching the ground. But then we came in and we burned. And after burning, we had even better results. We found over 50 of the white-fringed orchids, 20 of the yellow-crested, and 3 of these Camby's bog orchid, which is a hybrid between these two. And the bog orchid was really exciting because it had not been found in this area for 18 years. And we look back at the records, and 18 years previously, before this fire, there had been a wildfire on the same spot, and that orchid appeared. So there's a wildfire, there's this rare orchid, no more fire, and the orchid blinks out, and then fire, and then just weeks later, the orchid's back. And for me, that just boggles my mind. I've talked to orchid experts, and they're like, oh yeah, sure, they'll hang around. But it's amazing, and it just shows you that there's a lot of, that some of the seed bank really still can persist, and it's just waiting for us to bring fire back. So, okay, here's my first wildlife example. So here's an example of when the fire surrogate didn't work. So this is Cicindela abdominalis, it's the eastern pine barrens tiger beetle. And we have it on our Nasawanga Preserve, and it's critically imperiled. And it really likes these open sandy areas. It loves this transition between open sand and grass. And it's a really cool insect. Here it is as an adult, and here it is as an immature. It lives in these burrows. And when I see something like this, that to me screams fire adapted. I mean, you could just see the fire sweeping over the landscape, and this little larvae is just fine. But anyway, it's a predator, and here's the head, and it sits in this little hole, and when an insect comes by, it jumps in and grabs it. So we had this insect in only one part of our preserve, and it was right on a sandy road, because that was the only part that was opened and exposed to sunlight. And we were really uncomfortable knowing that the only population was being driven over regularly. So we really wanted to expand that population to get it off the road. So we did an experiment in which we logged patches of trees adjacent to that road, some with a buffer, some right up to the road, some we clear cut, some we bend. And we were extraordinarily careful not to use that road with our logging equipment so we wouldn't trample them. And we also did it during a time of year when the beetles were dormant. So we had these long skid trails away. And the results were disastrous. Despite all our efforts, the beetle population just absolutely crashed, and we were devastated. So that didn't work, no matter, even though we had been so careful. They did not like the logging, they did not like the disturbance at all. So then we went in and we conducted some control burns. And this is that landscape. When we first started burning here, it was, first we removed the loblolly pines. And it was pretty shrubby, but after, and you can see these sandy patches after we burn. After a couple burns, it really did end up having this really nice grass community with these sandy patches, which is what we had read that they needed. And the results were fabulous. So after the burning, so here's the sandy road. These stars are just grid marks, but what we were finding, and these are our little experimental blocks, finally with the burn, we found that the tiger beetles were really starting to move off of the road and onto the surrounding areas, which is exactly what we wanted. So now the tiger beetle has expanded in its range, while at the same time its population has increased. So a success there, but only with the fire. So here's a mixed success story. Lupins, eastern sundial lupins, love fire, and this is a species that we keep an eye on in Maryland. So we found that when we're burning, the lupins have just responded beautifully to the fire. But deer love lupins, and what's happening is the lupins are now attracting the deer, and the deer are just gobbling them up. And this is an example of an exclosure, just to show you that when we do cage them, they bloom beautifully, but if not, they get eaten. And right now we actually have a few electric fences, so we're not doing these wee little things anymore. But why do we care that the deer are eating our lupins? Well, the lupin is a host plant for the frosted elfin butterfly. And this butterfly is just on the brink of being placed on the endangered species list. So we really, really want to protect this butterfly. And what we're worried is going to happen is our lupin population has increased. The butterflies are going to come in, lay their eggs on the lupins, and then the deer are going to come and just gobble them all up. So again, now we've got some electric fences around a couple of really big lupin patches to protect them. But it's one of these balances that we're trying to find, in which the species are responding well, but then other species are, throwing us off kilter. I'm going to stick with the insect theme and talk a little bit about ticks. I referred to this earlier, that there are numerous historical accounts suggesting that burning through a forest reduces tick populations. And there's a number of different reasons for this. Ticks like it dark and moist. And when you burn, you let sunlight in and you burn off a lot of the duff and the leaf litter and the thatch. And that desiccates the ticks, it dries them out. So this is a study that we're doing right now in Western Maryland at our Sidling Hill Creek Preserve through Frostburg State University. Actually, their master's student just finished her study. And these people are dragging these white cloths through the woods to collect ticks. And we did in fact find a difference with fewer ticks in the burn areas. I messed up. I must not have saved. Apologies. I had another graph that's missing. There was another study similar. There was a study in, well, anyway, I'm just going to leave it at that. And then Elizabeth Gleim in 2019 published that she found that encounter rates with ticks was 98% lower in areas that have been burned. One of her takeaways was that you need to burn big and you need to burn often. And then here's a study down here that shows, and this is from this year, that the more often that you're burning, so here's number of burns and percent of ticks remaining, the more often you're burning, the fewer ticks you're going to have. And then the corollary here is the longer period of time that you have between burns, the more ticks you have. So frequent burns is what we're finding you need to really reduce the tick populations. So now I'm going to shift over to some wetland burn examples. This is our Dorchester Pond Preserve, and this is in Dorchester County, and this is a Delmarva Bay. So this is an ephemeral wetland. It fills with water in the spring, in the fall and winter, and then it draws down in the spring and summer. And when it draws down, it essentially becomes a prairie-like habitat. And these areas are very quickly closing in with trees when they're not burned. Gums and maples come in and invade. They draw up the water levels drop, more trees come in, and eventually you just lose these habitats forever. So this is an area that we burn fairly regularly. And I just wanted to show you one of these examples. So here's a picture from March, just before we burned. Here's April on burn day, right after the burn. And by June, you're already getting this amazing green up with all of these native plants, forbs, grasses, sedges coming in and responding to the fire. So this is a really exciting example of one of these wetland burns at a Delmarva Bay. This one's in Queen Anne's County. And at this preserve, we have the only population in Maryland of Canby's dropwort, which is a federally endangered plant. When we first bought this preserve in the 90s, we only had 2 plants. And this is the only location in Maryland. There used to be one site in Delaware with a plant, and that one's disappeared. So we really wanted to save it. And this was an example where this pond was starting to come in with trees and get overgrown. So when I started in 2001, I was tasked with opening these ponds back up. And I would go in and just physically remove the trees. We would bring in volunteers and we would just cut them down or girdle them. And that was pretty effective. That let a lot more light into the ground. The trees stopped pulling up all the water. And the population did start to come up. But what was happening is that other native plants like Panicum herbinibon, maiden cane, was also growing very aggressively and starting to outcompete it. And it was also creating a really thick layer of thatch. So what we wanted to do was burn, but we were nervous about burning because we didn't want to put in a fire line, which is generally what you do to contain the fire. It's a really sensitive area, and we just didn't want to disturb it. So what we did here is we used, the pond edge has this dark closed-in forest. So we use that transition from the open grassy pond with lots of sunlight to the dark closed-in wet forest as our fire line. So we wrote a prescription that said that a fire lit in the woods has to go out in order for you to be able to proceed with your burn in the pond. We found just that day, it was a couple of days after rain, we went out there, we tried to light a fire in the woods, it went out, and then we burned in the pond, and it went so well, and the plant responded amazingly. And now we have over 3,000 plants thanks to the burning. And we did another burn last year, so this August I'm going to go in and count, and I'm really excited to see what we find. And I'm going to show you an example of what that burn actually looked like, just so you have a sense. So this is me in the foreground. And right here, you can see the shade. So I'm right at the fire, at the edge of the forest. And you can see that the fire, and obviously this is sped up. The burn itself took about 45 minutes. So you can see that the fire is naturally going out as it reaches the edge. And on the far side, you can see there's one more igniter, and he's going across the far side. And now there's one igniter coming straight down the middle. So we were able to do this burn putting very little fuel on the ground, only 3 lines of ignition, and no fire lines. So a very, very low impact burn. And it did exactly what we wanted. And it just shows that these grasses, these plants just want to burn. And the amazing part is the pond was still wet. The sphagnum was still holding moisture. So even with a wet pond, just a couple of days after rain, these wetlands just burned so beautifully. So now I'll shift back a little bit into birds. So ironically, maybe wonderful coincidence, today on my Facebook reminders, I got a picture of this, a reminder of this picture that I posted 10 years ago. And this is at the Great Dismal Swamp, and I was visiting it after these tremendous wildfires they had in 2011. And I came across this killdeer nest, and I was just astounded at how beautifully these eggs are camouflaged by this, the charcoal around them. So that, to me, again, shows that this bird has got to have some sort of adaptation to living in a fire-adapted habitat, and obviously it's laying its eggs. So let's talk some about birds. Luca talked about how he's recording the birds in his backyard. Well, we've been doing a number of studies of bioacoustic to see effects of burning on our bird populations. And this has all been done by Gabe Cahalan, who's our burn boss. So he's doing this on the Eastern Shore in Assawanga, as well as in Western Maryland at our Sidling Hill Creek Preserve. So here's an example of his monitoring, acoustic monitoring devices in an open area. So this is an area that we've been burning frequently. And here's one that's closed that you can see how dark it is. There's a few sparse grasses, but really not a lot. And the results he's gotten are pretty tremendous. So in red is from the open area. So this is recordings that were taken from 4 a.m. to 10 a.m. He sets it to record for 1 minute every 2 minutes. And you can see the dawn chorus right here. And he's really gotten a tremendous amount of greater diversity and greater abundance in the open areas that we have been burning regularly. And this is neotropical migrants, residents, all sorts of birds are utilizing the burned areas with much greater abundance. And some of the increases he's seen are brown-headed nuthatch, blue-gray gnatcatcher, pine warblers. We've also just observed increases in bobwhite quail. We do hear more of them. We see lots more turkey and nightjars. I have a funny story for years we'd have burn crews who would stay on the Eastern Shore. We had a house down there that they would live, and they would just complain and complain about the whippoorwills that would just keep them up all night. And we were like, do you realize how awesome that is? So lots of birds have responded really, really well to this increased diversity. I want to talk a little bit about red-headed woodpeckers. We've really seen their populations increase dramatically at Nassawanga, where we've been burning. And we did a little research, and we found some really interesting studies that say it's not just that they benefit from the fire, but they really need areas with a mosaic of fire. They like these ephemeral, recently burned areas with a few branches remaining that can only last a couple years after a fire. So to bring in the red-headed woodpeckers, you need to be burning here this year and here next year and here the following year. And that's the kind of habitat that they crave. Gabe Cahalan, again, he's an amazing photographer. So just for fun, I'll show you a series of pictures that he has taken of these red-headed woodpeckers. They're just so beautiful. They're so striking. And it's terrific to see that they're just doing so remarkably well on Assawango. Okay, now I'm going to look forward and talk a little bit about red-cockaded woodpecker. I realize I'm almost out of time, so I'll speed it up a little. Red-cockaded woodpecker used to be in Maryland. It's a federally listed species. The last breeding population was in Dorchester County near Golden Hill. It was a mature loblolly pine stand that was clear cut, and when it was clear cut, the trees, the birds disappeared forever. Well, maybe not forever. There's also a few other sightings that occurred in Laurel in the 70s and 80s, but those weren't necessarily, they weren't documented as breeding pairs, and they're no longer there. There's a population in Piney Grove, Virginia, in a preserve that the Nature Conservancy manages that they burn regularly that's doing really, really well. But they've had a few springs that have been really, really hot, and the result has been really high nestling mortality. So it looks like maybe increasing temperatures are starting to have a negative impact. So maybe this is a bird that's going to need to start moving forward. So one of the experiments that we're doing here in Maryland at our Nanticoke Preserve is we've done a longleaf pine planting. And we've been burning this area regularly, and the longleaf pines are doing great. So perhaps if the red-cockaded woodpecker does need to shift north, we're kind of going to have a starter forest ready for it. I want to talk a little bit about bats. Bats also really benefit from fire. This is an Indiana bat. They really love after a fire when you get a snag and that bark starts to slough off. That's the perfect habitat for them. And this is a study that's showing bats, specifically Indiana bats in different trees. This one is a shortleaf pine with 28 bats, then a yellow pine with 75 bats, a table mountain pine with 8 bats, a pitch pine. So this is showing that when you're burning regularly through some of these areas and creating these snags, it's the perfect habitat for bats. But similarly to the red-headed woodpeckers, this is a really ephemeral habitat. This bark is only going to hang on that dead tree for so long. So again, it's so important to have fires in a mosaic of different areas so that the bats can move around. And this graph is from a master's thesis in Salisbury University that looked at areas that we burned and were unburned at our National Preserve as well as at Chesapeake Forest. And she also found that the burn sites had greater bat activity. This was an acoustic study. So in the last minute, I just want to show you a quick video of, I know I should do one video, but just to show a lot of times when we talk about fire, people get alarmed and they say, oh my goodness, it's just, aren't you just burning down the woods? And no, these frequent fires, the ones that we're working towards, generally sweep across the landscape, low flame lengths, and then you get this amazing resurgence of growth afterwards. And this is when that diversity comes in. So when we talk prescribed fires, these are fires that are done on very specific environments, and the result, they're fast, and the result is great regrowth. So I'm going to talk about that just for a minute. This is my last slide. A lot of folks come up to me and say, well, what about carbon emissions? Aren't you releasing all this carbon into the environment? So yes and no. When we're doing a prescribed fire, again, it's under really careful, specific situations. There's not a lot of wind. The humidity isn't too low. We have our fire line, so we know just what we want to burn. And we have these light, fast burns. So they're burning off that duff. They are killing some of those smaller trees, but the result is you get that amazing resurgence in growth for the herbaceous layer. And then the trees grow bigger, faster. Underneath, the roots grow longer and deeper. So you're sequestering so much more carbon than you release. And at the same time, those larger logs, they're producing charcoal, and that charcoal ends up getting locked into the soil, and that carbon is trapped for millennia in the system. as opposed to a wildfire. The mega fires that we're seeing out west, which are not natural systems, these are areas that have been fire suppressed for so long that you have these trees right next to each other. So when you have that wildfire, it just sweeps through the area, completely consumes the tree. It's so hot that it can even sterilize the soil. And you're burning not just trees, but you're burning cars and houses. So there's no comparison between the control burns that we're doing and the mega fires that you're seeing today. And that's what I've got. So thank you. And sorry if I went a little long.
Great. That was great. That was awesome. I learned a lot. I loved all the citations and the studies. I was taking notes as I listened. So thank you. I'd like to everybody give her a virtual round of applause in your muted Zoom rooms. But all the attendees are welcome to, if you have questions, to pop something up in the chat button in the middle of your screen. I know I have a couple. I'll let people start typing their little questions into the chat, but I always like to have one in reserve because I was listening and thinking about it. I loved the tick stuff. That was one of my questions, and then you really got into it. So that was really great. I've been on a couple of prescribed burns. I've had the chance to do that and start some as well out in California mostly. But I know sometimes it can be hard to get burns going if things are too green or if, and you mentioned burning on that wetland area that had just rained a couple of days earlier. How hard is it for you to get the conditions right where you can actually get a burn going? Is it kind of a tight window before things get too green? Is the middle of the summer impossible to burn because this stuff's too green? Or
Right.
elaborate on that?
That's a super great question. The answer, of course, is it depends. In some areas, like the wetlands, yeah, they'll just burn right across. They'll dry literally in hours. But there's some warm season grass fields that we do have a window after which we can't burn for ground nesting burn, which is April 15th. But often before we hit that date, that those grasses do start to green up, and then they'll no longer carry fire. So it depends very much on the habitat. Summer would be a great time to burn, but yes, a lot of the vegetation is too green and we just can't burn there. It's just a lot of our resources, like the Forest Service, they're out west fighting wildfires. And it's harder to contain the fire sometimes. So we don't have quite the weather parameters that we need.
Mm-hmm. Cool. Everybody in the audience, be thinking of your questions and please do type them into the chat. Well, I'm watching that, but I'll have another question. So for small acreage landowners, say they have 3 to 20 acre sort of parcels, and you mentioned the Native Americans using fire to clear creek bottoms and riparian areas. I'm curious. Well, I guess there's two questions. One is what does that look like in a riparian area and the ecology? And I know there's a lot of areas in, say, the Western Shore. I've seen creeks that are just full of downed ash trees all over the ground. Like it's impassable in a lot of ways. Is that the kind of place where people might want to think about fire? Or is that all that downed wood just too much of a liability to think about burning?
Yeah, that's not a natural situation, so I wouldn't burn there. And for the riparian areas, it really depends. Because say it's a hemlock stand, assuming they're not dead with the Delgin, that's not an area that you would want to burn. That's the hemlocks are playing an important role shading out the creek. But there's some areas that maybe you want it more open. Again, it's a cop-out answer, but it really depends. It depends on the system. It depends on the ecology. Out west, it might historically, I think more of these areas, the riparian areas, were more open. Whereas here in Maryland, particularly in Western Maryland, the mountains, they tend to be shadier habitats.
Mm-hmm. Interesting. Cool. Any other questions from our audience? Please do feel free to chime in there. We have a comment. Somebody said they really enjoyed the talk. I can keep going with more questions. Let me see what else I had. I think, have you personally noted a tick reduction? How's your experience with the ticks? This year seems to be crazy at our research farm. Everybody's getting 3, 5 ticks on their pants before they get into their car, and then they find them crawling on the dashboard the next day. So
Yeah.
how's it going?
So I can tell you two things. First, in 21 years of field work, they're definitely getting worse overall. But yes, I absolutely can notice a difference if I'm walking through an area, particularly an area that's been burned often, so that we've gone back 4 times and burned. Absolutely. I'm less likely to walk through one of those nests and be covered in the seed ticks. There's far, far fewer, more likely to encounter, say, a dog tick, one that was probably carried over or traveled over than a nest that originated from within the burn unit. So yes, absolutely.
Great. How can homeowners this is kind of related to that one earlier with like the creeks, but what about how can homeowners or even larger landowners get started if they want to do this? How much acreage do you need to work with neighbors to get a minimum sort of threshold to make this even feasible to do? If you have 5 acres in the back, is it sort of out of the realm? Or can you elaborate on how would you go about evaluating whether you would need whether a fire would be beneficial, and then if it is, how do you then get around to implementing it?
So the first thing you need to do, and all landowners should do this, is get a forest management plan. Reach out to your county forester and meet with them, talk about your plans for your land, and have them put together a management plan. And these are so important. We have such a treasure trove of knowledge in our foresters' heads, and it's just a terrific thing to do, period. You never know what's going to happen to you, and just have a plan in place for how this land should be managed. So once you have that plan in place, if the forester worked in fire, that fire is necessary to maintain or restore this area, then you can try working with your local county foresters and seeing, some counties more so than others. Sometimes it's more grasslands, but some of our county agencies will help private landowners with fires. 5 acres is a little small, but I'm not going to, that level of detail is hard to talk about because it depends. It could be grass, and then sure, if it's woodland, maybe not so much. But you should always start with your county forester and meet with them and talk about your land, and they will help you decide what is realistically feasible and
Great.
best.
Great. Well, that's all the questions that I have written down. And I agree. The Maryland DNR's Forest Service does a great service. If you have some forested area and want to learn more about it, I agree. Getting a forest management plan seems like the first ticket, and not only it is, I believe, one of the tickets to get property tax reductions on a property, as well as learning a lot about your forestry practices, and you can also then qualify for, I think, cost share programs. Is that the WIP? Is it WIP?
There's WIP, there's CREP, there's EQIP, there's numerous programs that you can enroll in, but yes, you have to start with that plan. So I'll call it a win-win-win.
Right.
Yes, and you learn about your property. Yep.
Right. Great. So if anybody on the phone wants to learn more, wants to manage the forest, that is a great place. Oh, we got a question. Christopher Aiken. What about fires in the buffer areas to regenerate understory plants for soil stabilization?
Great question. For soil stabilization, fire is one of your most powerful tools, because again, when you burn, it encourages tremendous root growth. So, and you certainly could do buffers, especially if you're talking about ag. After you've cleared the fields, that could be a pretty straightforward burn. So yes, I think that's a terrific plan. And yes, there's loads of studies that show how good fire is for soil stabilization on terrestrial areas and marsh areas. Absolutely.
Do you try to wait until rain is forecast, or like a light rain, so you don't get can you get some of this sort of, if you have a really intense storm right after a burn, do you worry about that?
Again, it depends on the habitat. Grasses, you can go hours after a rain. If you're doing these up the forest burns, they can take a really long time to dry. I love when it rains after a burn, unless it's going to come. If it's a system that brings wind before the rain, then that could be really bad news. So it really, really depends.
Right, right. Great. Christopher also followed up and asked, do you coordinate with critical area COM in that they are totally against touching any vegetation? I'm not sure what critical area COM.
I think maybe
Oh, and critical areas around the Chesapeake Bay, I guess.
So we do all of our burn planning in conjunction with the Maryland, with DNR, DNR Forest Service, DNR Heritage, and they burn with us. So we are able to burn through some very sensitive areas, including some mapped, numerous mapped wetlands. We do sometimes have to get extra permits and have some site visits, but we are able to get it done.
Great, great. So it sounds like coordinating with your DNR, it sounds like it is possible to get burns done in critical area then?
We have.
So yeah, it is possible. It is possible, Chris. So great. Well, we're just coming up on the 1 o'clock hour. I've learned a lot. I thank you, Dr. Landau, for sharing with us for your knowledge and your experience. Congratulations on your promotion, and look forward to continuing to learn more from you in the coming weeks, months, and years. So thank you everybody for joining, and we will have this up on YouTube here in the next few days.
Thanks so much for having me.
Take care. Bye-bye.